Welcome to the lecture number 2 of Generative AI. So today we're going to learn about tokenization, embeddings, and transformers. So you have previously used ChatGPT, right? Maybe 10 minutes ago. And do you know how does it work? So you would say something like, it's a predicts a word or something. And that's not wrong, but it's also not an answer. But there are more things to it. So let's understand. When it goes to an LLM and say, hey there, so the hey there doesn't goes to the LLM. The hey there, that is the input, is first converted into numbers, and then the LLM predicts the next number. Then this next number is again converted back into a characters, and then this character is the output. So this follows a loop, and this thing works in a loop. So it predicts the next output, and then it's just loop and loop and loop and loop. So this process is known as tokenization. The converting into the characters converting into a number is called a tokenization, and the same thing, the numbers converting into characters, is called de-tokenization. So why tokenization matters? First, we understand the problem, why we do tokenization, and then we will get the answer. So what's the problem in tokenization? So the simple problem is the bridge problem. Means why a neural network cannot read a word, means cannot read the characters. So this is a diagrammatic representation of a neural network. So basically, what is a neural network first? So a neural network is a computational model inspired by the human brain, designed to recognize patterns and solve complex problems. So it consists of interconnected layers of nodes. So this all things we call it nodes, and there are three layers in a neural network. One is an input layer, and one hidden layer, and one output layer. So the hidden layer can be multiple hidden layers, not just a single layer, or multiple hidden layers connecting a deep neural network. So what we call, and here there are some weight and biases. Means think of it as a key parameters that are used for adjusting during training, that dictate how much the input layer has an influence to the output layer, and we can control, and we can adjust them through biases or weights, right? There are also activation functions here. So means it determines if neural should fire, means to activate based on input. Means, so that's it. I am not going deep into it because it is generative AI, right, and not machine learning. So yeah, here is the problem that tokenization solves, and it beautifully simple problem once you see it, right? A neural network at its heart is a giant stack of matrix multiplication. It can multiply numbers, it can add numbers, it can compare numbers. What it absolutely cannot do at any level is read that there is a letter T, then there is a letter H, then there is a letter E, and somehow you wrote TH da. So TH is a word da, but it cannot understand that this is a word, right? So before any transformer, before any attention, before anything that looks like intelligence, we have to solve a very dumb sounding problem. What is the problem? How do we turn text into numbers in a way that network can actually learn from? Means this is what tokenization is all about, right? So coming to it, there are two types of worlds, right? A human world and a neural network world. So in a human world, the cat sat. This is a complete sentence, and it has a context, a grammar, and a tone. So we all humans live in this world, right? And there is another world called a neural network world. So it just cannot see the sentence and understand what the word is all about. A neural network cannot read the word or the sentence the cat sat. And what we do about it? So core problem is in this diagram means human live in a world of letters, meaningful context, and everything. Networks live in a world of numbers and matrix multiplication. So it does some matrix multiplication and it gets that, yeah, this means that, right? So before you appreciate the bridge that it solves the problem, right? So see what's on the other side. A neural network is not a brain. It's a stack of matrix multiplication, right? So what the network actually is, so there is some input, a vector x, and a weight that I have already explained to you what weights are all about. And means these are some learned parameter weight, and there are some activation functions like ReLU. This is a non-linear activation function. Activation function is applied to the output of a neuron, means it introduces non-linearity, enabling the model to learn and understand complex data, right? Every layer, every model, all of it, multiply by a matrix. And then we get the results and then multiply again. Repeat this a billion number of times and we get it there, right? So let's understand the bridge first, means how it works. For understanding it, let's see some visual representation and then we'll come back to this diagram. There is a website called Tokenizer, and here you can see how a text is broken down into tokens, right? So I have chosen the Google Gemma model, and if I write, hello, I am learning tokenization today, right? So as we can see, today. So as you can see, there are 1, 2, 3, 4, 5, 6. There are 6 words, and we get 9 tokens from it, right? So the word hello is converted or tokenized into the digit 2. Similarly, the comma is 4521, the I is 235269, the learning. So the word tokenization is broken down into 2 tokens. One is token and one is iJSON. So for the token is 6044 and iJSON is 8447. Here also interesting thing, right? That for every model, tokenization happens differently. So as you can see that the model here selected is Gemma 7B, and if I click on it and choose a different model like GPT-4o, suppose. So if I do the same word like hello, I am learning tokenization today, and you see that the same thing that I have written in Gemma has given me 9 tokens, but in GPT-4o it has given me 7 tokens. So this is how tokenization works. Every model has a different method for tokenization and de-tokenization. And so these are the numbers which are sent to the transformer. And what transformer is going to do is, transformer means the model as we have seen in lecture 1. So the transformer is just going to predict the next token. And now if we see the diagram, you can now understand properly. Like this is a human side, as we have discussed earlier, means the cat sat, the word. This is the raw text that we send to the LLM, right? And then in the step 1, it breaks it into 3 different words, right? The cat sat means the text is converted into tokens. And in step number 2, it look up for the IDs, right? Means the is converted into digit is 460, means it, suppose for the model of GPT-4o, there it is embedded, or you can say hard coded, that the word the will be converted into digit 464, the word cat will be 2415, the word sat will be 3332. So in this process, the tokens are then converted into integers, and then in the third step, as you can see, this IDs means these digits are then converted into vectors, right? And then we do matrix multiplication on the machine side of the neural networks to get to predict the next digit, right? As we can see that, suppose for an example, if there is a word India and there is a word like capital, can you guess what will be the coming next possible word here? I'm giving you 3 seconds. 1, 2, 3. Yeah, that's right, Delhi. So the model knows that the probability of the word India and the probability of the word capital, if these 2 words comes together, then there is a high chance of probability that the word Delhi will come next, right? In step 3, these tokens are then sent to the LLM, and what the LLM do? That's right, it predicts the next token. And then it repeat the process, repeat this process, repeat this process again and again and again and again and again, and that's how it works. And when you get a very big number, like a big series of number, then you de-tokenize it in the English language to send back to the user. So just to sum this up, raw text, the transformer uses this for attention, and then in the tokenizer splits into reusable support pieces. Like the word tokenization might be a single token in one model and 3 tokens like token ISN in another model. And then this tokens are further converted into token IDs, and this the whole thing is called a neural network. So a token is not a word. This is the first thing I want you to unlearn. In model language models, a token is usually a piece of word, what we call sub-word unit. So now let's code our own tokenizer. Yeah, we can code our own tokenizer. It's pretty simple. So I have my VS Code open, and let me just create a file. So now first we have to create a virtual environment. Okay, so let's create our virtual environment by writing. Just you have to write Python. I Python 3, so I will write Python 3 minus m virtual environment, and I am going to name it virtual environment. So virtual environment. And you can see that a virtual environment has been created, and now I have to activate it. So I have to just write source, um, the name of my virtual environment slash bin slash active. Yeah, a virtual environment has been activated. Now we have to install a package. So we just say pip install tick token. So tick token is a package made by OpenAI company which helps you to tokenize and de-tokenize. So now I'm going to write a command that is pip trace, and now I'm going to pipe it to a file name requirements dot txt. Yeah. So this command will just create the requirements.txt file for me, as you can see here. And these are all the packages that are installed. Now let's go into the main and start decoding. Now I'll just say import tick token. So tick token is the package. Now what we have to do is we have to get an encoder. So encoder equals to uh, tick token dot encoding for model, and we have to just give a model name. Let's say 4, right? So what I'm doing here, I want to create an encoder for this model here. Let's say my text is, hey, I am learning to read my own tokenizer. Okay. Now I will just simply say that, hey encoder, can you just please encode me the texture? Means this is the text variable. Please encode this text for me, right? It will just return me the tokens. So let's just get it in a variable, and now let's just print it. So print mm, tokens, comma, tokens. Yeah. To run this program, we will simply run it in the terminal. Like we'll just say Python main.py. So as you can see, this is the output that I'm getting. Congrats, you have just made your own tokenizer. So I'll just paste it here. These are the tokens that I just got for this text, as you can see. Now, very important question. Can we reverse tokenize it? Means from the numbers to the text. Of course, we can do that. So just I will copy this numbers, and I will just say, hey, encoder, just decode uh, this, and let's try to print the decoded numbers, right? So just have to write print decoded and decoded. So now the numbers make no sense, but let's see after we decode it what this comes to. So let's run the file again. And as you can see, these tokens with this and our decoded just write the same thing. Means it has decoded the same text that was there. So this is how a tokenizer works, and this is how a decoder works. So what happens is these tokens are passed to the LLM, and the LLM keeps on predicting the next.